all your fault with all.
Is that
It's all your fault, Team USA won.
baseball?
Yeah,
You know,
it's because you spent all that time and I wasn't there to watch.
you were watching that. You missed a couple of minutes.
No, it doesn't matter. Our bats didn't show up.
Yeah, there were 2 runs.
Not against that team and the way they were pitching.
The other question is, how could the MLB let their players who are under contract play in the World Baseball Classic?
I'm sure that's actually agreed upon in advance.
I think it was put on, I think, by the MLB.
Right.
I think the reason for it is that I believe,
It cost the Mets $20 million a couple of years ago.
I'll say this, well,
With Diaz got blew out his knee there.
And as is very well known, Steve can afford $20 million.
Oh yeah.
again,
Without even blinking.
and he'll afford even more once his casino's up.
This will be okay.
He'll be okay.
Probably not for Steve Cohen,
What I will say is,
AKA Bobby Axel.
he is the.
That was a good show. I like that show, Billions.
Well, it was Bobby Axel then. That was modeled after him, and the attorney was Preet Bharara.
I thought the same way pre my finance career with the whole, why would you put them out there and risk them? But all they see it as a loss leader, because if they can generate more buzz and more fans from doing the World Baseball Classic, which I think they do,
Oh, definitely.
they'll make more money in the long run.
That is the decision. It's a good promotion.
I mean, I have people stopping me in the street because of my USA baseball hat.
There you go.
Nobody ever does that with a Yankee hat unless they're a Red Sox. Did you watch? Did you
No.
watch? No? Are you just not a baseball fan, or you just,
I'm a Mets fan.
oh, you have a lot to complain about.
Yeah, I lost Diaz for a whole year when the Mets actually might have been able to do something.
I hear you. Where's Diaz pitching now?
Dodgers.
Oh, that's right. The new evil empire.
No, you're still the evil empire.
Go Yankees, baby.
Don't kid yourself.
Go Yankees, baby.
I like the Eagles. I like the Mets too.
Mets are our little brother. I'll say this. I have much more fun at Citi Field than I do at Yankee Stadium. I've been in the owner's suite at Citi Field. It is gorgeous. That stadium is awesome. Sentimentality.
See, the Mets are going to run a ferry from Stamford to Citi Field nowadays.
Say it again?
The Mets are going to run a ferry across the Sound from Stamford to Citi Field.
Are they? I'd go just to ride the ferry. My kids.
It's
love it.
like 10 or 15 games, mostly on the weekends, I think. But they just announced it in the news the other day.
That's pretty cool.
I don't think it's that cheap either. But
Well,
neither
it's
is
an
driving.
experience.
The ticket may be included in the price, though, too,
I would hope so.
because it was a couple $100. But I haven't been to Citi Field. I've been to Shea Stadium a lot of times, but never to Citi Field.
I went to Shea Stadium once, but I don't recall what it was like. I went as a kid. But
I went to Shea Stadium in 1972 when I was 11 years old.
God bless. I went to Citi Field about pre-COVID, of course, but I think it was in.
Supposedly, all of Citi Field will fit inside the upper tank of what Shea Stadium was.
Really?
Yeah, Shea Stadium was big. It held 55,000 people.
Holy shit. Why would you shrink it then?
They couldn't sell the seats.
Come on, you got Juan Soto now, man. You got to put another bowl on that thing.
This was Citi Field was in 2008, maybe they opened it.
Something like that.
I can't justify going to a game when I have a room full of 85-inch screens in high definition. I can't do it. I'm in a comfortable seat. It's 800 degrees in New York in the sea in those stadiums.
I'll do it when my son looks at me and says, "Dad, can we go to a baseball game?" Or if I can get into a suite. Because it is brutal out there in the sun.
Oh, yeah, I'm not gonna sit out in the sun.
I do it enough now that my son plays travel baseball. I'll be sitting in the sun baking, watching him do that. I'm sure you missed that, right? I don't know if there are any parents in here that used to do that. Try.
A couple seconds here.
I remember going to Shea Stadium in the middle of summer for a 20-night doubleheader because they get rained out like the day before. And it was so hot, I just went up to the top row of the upper tank just for the breeze going across the roof. And I sweat so much, I didn't even have to go to the bathroom the whole time I was there for 2 games.
I mean, that breeze had to be brutal in itself, but at least it was better than
It was
this.
moving air, at least. Convection heat transfer beats radiation heat transfer any day of the week. Any engineer will tell you the quickest way to cool your drink down is to run it under cold water in the sink, then put it in the freezer.
Are you serious?
Yeah. You got cold water?
I gotta try that. My poison is football anyway, and I'm a bear. I love the cold, so I'd rather go sit in 0-degree weather and watch a football game than 100 degrees at a baseball game. Me and my son actually did it 2 years ago. We went to the AFC Divisional for the Baltimore Ravens, diehard Ravens fan, my son. And we went to Baltimore for that game that was basically in the snow against the Texans. I almost lost my toes because we were basically sitting in a puddle of snow and I had him on a chair.
In the 90s, I worked with a nurse at Norwalk Hospital whose father actually had season tickets for the Giants about the 30-yard line on the lower deck, about 20 rows up. So she let us go at least once a year. So, but once they went to the new stadium and had to buy the PSLs, they had to give the tickets up because they wanted $20,000 a seat or something for the PSLs.
Yeah, I think it's like $15,000 to $20,000 or something like that. Sporting events are not for the bargain brand consumer anymore.
Yeah, but her father had the season tickets since the Meadowlands opened up in the 70s and had to get rid of them just because. Actually, I think he was dead by then. But he had to get rid of them because couldn't afford the PSLs for the seats.
It's a shame.
The Mets doesn't want to play with us anymore?
Wasn't the Mac, wasn't,
No, Matt.
What?
Your partner, Matt.
No, he's coming back. I'm gonna teach this week and next week, and then he's gonna come on the 8th. And then I'll teach the rest of the classes. I asked him to switch because I needed to do some other stuff.
Should have power. I got power here. This has got power. So should have power there.
I don't know, those don't work either. Where is this connected?
I know the middle row inside there has power. I've used the power in the middle row. The inside row, I should say.
Thank you.
Right, okay, let's get this ball rolling. So, I got to meet with two of you, on video over the break. The offer remains open to anybody who wants to help, discussing the Python setup and how to make it work more to your advantage. I got an email from one other person who had no problem with it, so that person is also considered good to go. It was helpful, yeah? Right?
100%.
So, I've got some interesting stuff for tonight. So I had hoped that there's another book I like for this class, but it had gotten kind of old, out of date in a way, makes the libraries hard to use, and consequently, I didn't want it. But it's coming out in a new edition, so I was hoping it was new edition was printed in time for our class, which is why I didn't specifically recommend the other textbook to purchase. But we're going to do some work with the first textbook that was mentioned in the syllabus under my class. It's a good textbook, it's not bad, but it's also getting a little old, and so consequently, you have to fiddle with the libraries a little bit to get it to work. And but it did bring up an interesting point about the principal component analysis, which I talked about last week, and my questions about the code that I had given you. We'll talk about that in a few minutes. Let me get the okay. What's going on here? This guy's dead now because I was using it. But so kind of the interesting questions, things have really changed. I've been teaching this class with Professor McDonald for about, this is probably year 5, maybe year 6 that we've done this. And things are changing. There's just no two ways to avoid the fact that you're going to be asking large language models to do a lot of the coding work for you. And what does it mean to even, why learn Python in that context Obviously, learning to read Python is a good thing, because if you get code from an LLM, how will you know that it does what you think it does? Or how will you even know the meaning of what it does if you haven't learned how to code, right? So this is, I gave you some, let me put the book up here, actually. Like I said, I'll show you a couple of books. Let me see here. So the one that we're going to use in tonight's class, well, I'm going to open this one too. My internet connection holds up. For some reason, Wi-Fi is having trouble connecting to Yukon. There it is, we got it. So this is the book I used probably the first 1 or 2 years I taught this class, Machine Learning for Algorithmic Trading by Stefan Jansen. And this second edition came out, I think in 2021 maybe, July 2020. 820 page, quite a long book. Great notebooks, it's probably 30 chapters with good information, and he's really got a scientific approach to how you can use machine learning in the context of algo trading. And we're learning about machine learning, so whether or not it's algo trading or other purposes, I think it's also mentioned in the syllabus. But then the other book that I've used a couple of books in this class. There's a lot of, not every book does what I wanted to do, but they have enough for the purposes of our class, which is to discuss machine learning ideas in the context of finance. And this book, O'Reilly book, Machine Learning for Data Science, Blueprints for Finance. And this author, and this book also came out in 2020, so his book's getting a little old in the sense, not that so much the material is old, but that the library's become dysfunctional. For example, with today's book, so this was July 2020, so long story short, he's working on the 3rd edition. He thought he was going to have it at the end of March, but I'm going to guess it'll be sometime in the summer. The 3rd edition is going to be 1,200 pages, I think. I think it's a good buy. Packet books tend to be kind of cheap. I buy Kindle ones all the time. Actually, I have an O'Reilly subscription, so I use that for free.
You sent one out in the fall too. You told us to download it was free.
What's that?
You sent one out in the fall too.
He's having one out in the
No,
fall?
you sent us a link in the fall. I don't know who else you sent it to, but
Yeah.
about a book you got.
I'm not sure which one that is off the top of my head, but so we're not going to use him right now because I abandoned it because it became too difficult to get all of his code to work. A lot of the major library he used for machine learning, right? I have the course in the fall called Algorithmic and High Frequency Trading, but a lot of his, even some of the libraries are even defunct now. He used to do a lot of data using Quantopian, I think, which was absorbed into NASDAQ. It just makes things hard. This book by Hariam Tatsat, Sahil Puri, and Brad Lukabal. It's a good book, and we're going to look tonight at the topic that we were discussing last week, which is unsupervised learning dimensionality reduction. And the context of principal components analysis, that's the one we're going to talk about. He's got a couple of different techniques. We're going to talk about the one that uses principal component analysis. And we'll see that the results on the interest rates PCA in this book are going to look different than the ones we got from my session with Gemini, and which I told you last week kind of surprised me that well, let's pull up the Gemini results from last semester, from last week, I should say. So running our Fred PCA2, Yeah, so this was the level weight, the factor slope, and the yield curve. So these are the standard factors, but the part that I had found dismaying was that the level was only capturing 81% of the variance in the data set, which are the changes in the interest rate curve. The slope, 9%. We got to 95% with this one. We run another one, go a little further. I guess I have to close those things. And more will pop up. The second round, the 5-year period between 2005 and 2009, 61, 26, and 6. So this is a very low number for US interest rate data. I normally expect that to be about 90. And so I'm like, I wonder what's going on here.
We had a little big
And,
disturbance around 28.
what's that?
You had the big disturbance in 2008.
Well, there's the fact that this doesn't conform to what I normally expect to see doesn't mean it's wrong, but it does raise a red flag. And as a quantitative analyst, I said, I'm going to need to look at that before I show it to my boss, and he or she calls me stupid. In more polite terms, probably, unless they lose money on the decision, in which case it might not be as polite. And so this goes on, and we'll just to give you a taste of where I'm going with this. If I pull up my session here, okay. So and I'm going to show you how this book looks, and this will be also back in the Jupyter Notebook format. So you may find that more easy to rock. Okay. So this is the yield curve management and interest rate modeling component. Go there. So I hit the run button. I already have this working, so I'm just going to let it keep going. I'm going to keep going with it. And now this one had relied on a library called Quandl, which I factored out because Quandl is it's still available. It wasn't in this space, but actually I don't even know if you can use Quandl anymore. I think you can actually still use the Quandl library, and it talks to NASDAQ, and NASDAQ bought it, and you can still use your API key. But these had, you notice he was using Fred as well. We got Fred directly last week, so I just went ahead and gave it the U.S. Treasury data that I'd already covered, rather than try to figure out all the Quandl stuff in advance. I load the data, and you can see, and this is the exact same data, because the data I just used to run in PyCharm is the data set for this. And you can see 367, and these are the rates, okay? And then we also get the tail of the data set goes out to, this one, they both say head. Might as well just make this one say tail. We'll complain because they're written on those other cells, so let's just run them. Oh, by the way, so this one thing I do like about this author's book, in the early chapter, he creates this 7-part system for which you should apply machine learning thinking to your problems in financial services. Step number 1, is to find your problem. Step number 2 is getting started. You load the data and the Python packages. And then this is replicating this. So number 1, he loads the Python packages, NumPy for matrix calculations, pandas for tables, matplotlib for drawing, good stuff, more pandas. So he imports, by the way, what happens here, when you import pandas as PD, anything you want to use from pandas, you put PD dot and you express that. Whereas if you directly import the name readcsv, you can use readcsv without prefacing it with the PD, as we'll see. Similarly, other stuff here. Import Seaborn, which, as I mentioned, as SNS, this is the letters that are often used there, is basically a copy over to Python of the graphic system that Professor McDonald's been showing you in R, at least the look and feel. It doesn't have all of the stuff that's in the Hadleyverse, but it does have some of the nice looking features. And from scikit-learn, sklearn, pre-processing, import the standard scaler. We talked about that. Standard scaler subtracts the mean off of every data point and divides by I think it divides by the standard deviation, or it divides by the max, I think, so it puts it between the min and the max. It puts the min and the max scooted down to between 0 and 1. Or maybe it's standard, means divides by the standard deviation, I'll have to relook that up. And then it also imports the PCA algorithm from the sklearn decomposition. Okay, and so we get our data in, and let's see. Okay, we load the data, and we take a look at it, right? Always take a look. And look at the tail. The tail goes out to 2026, 2 weeks ago, basically, or 3 weeks ago. Okay, then it says, the next phase, if you're going to do a data science related project, is you have to do what's called exploratory data analysis. Before you start trying to manipulate the data into whatever answer you're looking for, you should look at your data. Take a look at it as best as you can. Some basic questions. How big is my data? Well, this one has 6,000 rows, which we said is like 25 years times roughly 250 data points per year. Okay, 10 columns, 1 month, 3. He actually, when he imports it, he also pulls the 6 month in. We don't have that, so I'm not worried about that. Set options display with, kind of interesting. I've experienced this thing changed over a few months, over a few years. This set option, set options was one of the things we imported for pandas. Set options, just a way to manipulate the way your data frame looks. And let me just change this to, I think it was width. So I think the original, if you pull this notebook down directly from GitHub, you'll see you get an error when it tries to execute this set option field. So what do you do with this? Well, you can see, look, this is where I got my error, and then it says I go down into wherever and I do some stuff. I don't worry so much about that. I really want to find out where the error is, but all I would do, of course, is just copy this whole thing right into Gemini, and it will tell me almost instantly what the problem is. Now I've already fixed it here, so I'm just going to go back and fix it. Okay. And again, for those of you who are new to programming, I cannot emphasize how much easier this is than the old way, which would be to maybe cut a piece of the error message, paste it into Google. It would bring you to a website called Stack Overflow, which had lots of people answer questions over the years. And usually, if you've got the problem, somebody else already had it. But it would take 20 minutes to solve the problem. Now it takes 30 seconds. Okay, we display the rows. And so now look, this is his standard way of looking at the data. Well, what kind of data do I have? And you see, well, these are all floating point numbers. They're not always going to be numbered. They can be something else. And now data visualization, describe. He likes this one a lot. I never use this one myself, but anyway, it tells you, you can see that all of the columns have full data. If there were some missing values, not all numbers would be the same, and you'd have to decide, how do I deal with the missing data? The mean of the interest rates over the period, the standard deviation, the min got to 0 here, at least to 3 decimal places, and then the 25th, 50th, 75 percentiles in the max. So you get a look at the spread of your data, okay? And then data visualization, this is nice. Let's look at what the data looks like, and you can see your 10 tenors. You see they move largely in step, right? There was a period, 2004, where the longer rates were significantly higher than the upper rates, but then this period here in the middle, they're really jammed in very close to each other, so the yield curve had compressed, right? And it's nice. Now, of course, the point of using other people's Jupyter notebooks is, if you find some of this stuff interesting, you can go ahead and copy it into your own work. Also note, they were moving in lockstep here, but down here, they really spread out. The bottom, you can see, this was the 0 interest rate period, hung at 0 for a lot of years. And then you can actually see it happened again in the post-COVID, right, and then you can see the inflation spike that hits in 2022, and all of the rates move up by a lot. This is obviously, this is the Fed hiking. The blue line, which is the bottom, the 1 month, it's a proxy for the Fed funds rate. The blue line is the one that the Fed sets, and engages in what's called open market operations to enforce. So the Fed will do stuff in the overnight market to either push rates down or pull them up so that it stays at its target level. That's how the Fed makes that work.
The longer end is controlled by markets though.
What's that?
The longer end is controlled by.
Everything
markets.
else, everything except the very first interest rate, which is the overnight rate, is controlled by the Fed. But you know, like if the Fed's paying 25 basis points and someone wants to borrow money for 50 basis points for the 1 month, you can lend it to them because you know that the Fed's gonna let you borrow the money at 25. So that pushes the rates very close in the front end to where the Fed wants it to be. The back end, the Fed also has controls over the back end. What's that called?
They put money in and money out, quantitative easing. or
Yeah,
whatever.
quantitative easing and quantitative tightening is when the Fed buys treasury bonds essentially. If the Fed buys treasury bonds, that pushes the long end down. And they did a lot of that. You know, how do they keep these other rates from, you know, getting out of control? That's quantitative easing. You know, they sell enough treasuries to push the rates. They buy enough treasuries to push the rates down.
Then you get tantrums.
What's that?
Then you get tantrums in there at some point when people get mad.
Well, Kevin has
Well, it's
that.
complicated, you know, the Fed's job is not easy, but it's been largely successful. A fair amount of criticism that maybe they didn't hike quickly enough in 2022. Back in 2001, when they didn't want to cut rates in advance of the election because they felt that it might give an unfair boost to the Democratic Party in power, you know, the power. So they waited until December. At that point, it was probably a little on the late side. Had there been no election, they almost certainly would have cut in either July or September. And but in a way, it didn't really matter because the bubble was about to break and the economy was going to be due for some rough years in 2001. Okay, then they pull up, let's look at the correlation matrices. And it's always worth asking here, are they correlating changes or are they correlating rates? And since we haven't done any calculations that would calculate the differences in the move, they're just correlating the rates. And you can see that this is pretty typical of a correlation matrix associated with any financial quantity that trades at different tenors, whether it be a treasury curve or a commodity curve for natural gas prices or oil, that the closer they are in time, the closer they'll be to one. But the farther away, the back end can decouple from the 1 month, okay? So the 30-year, the correlation is only 50%, so they are related, right? They're, 50% is still a pretty strong positive correlation, but it's not 90.
That's a pretty close correlation between the 5-year and the 30.
Yeah. So once you get out, further out, that there's not that much movement, and we'll see that in that third principal component, which really measures the two ends versus the middle, doesn't really explain that much of the variance. That's because there's so much high correlation between the back end and the front end, right? And even the 5-year and the 2-year, let's see, column 4, 1, 2, 3, 4. The 5-year and the 2-year at 94%, right? So that's also pretty high. Okay? So you can see this is a useful kind of scheme that the author has cooked up. Data preparation. So this is an important part of data analysis that we haven't discussed much, and I'm not going to discuss much. Maybe Professor McDonald did, but you have to look at your data and like what happens if there are missing values. Missing values. This data set's pretty clean. It's maintained by Fred, but data you get from other sources can definitely be compromised, and just missing numbers, or it could be bad numbers. Missing numbers is easy enough. You have a missing number, and you got to figure out whether to drop that row, let's say, which would say that date didn't happen, or you could drop the column which says this tenor doesn't exist. Dropping data is sort of a bad thing because you only have so much data, and data is valuable, so you try to avoid it. A lot of times what you'll do in a time series of financial, you might do what's called a forward fill, which is for the missing rows, whatever happened yesterday, copy it into today. But if you don't look at your data, you don't really understand the impact of that. Like if you look at certain relatively illiquid natural gas locations, you might find that in the past 4 years, there's only been trades at that location 25% of the available days. And other days it just doesn't trade because that's just the nature of the market. It's sort of an obscure market. Well, if you fill in all of the rows forward, like these prices existed, you're gonna start to make inferences about the relationship of that price to other prices in your time series that maybe aren't really valid, right? So you have to, you gotta decide what you're gonna do. It's a problem of data science in general. But what he does here is he says, I'm gonna forward fill the missing values with the last available. I guess this is just two different ways you could do it. These are three choices. You wouldn't do all three of them, you'd only do one. Forward fill just means copy into missing rows. Drop on axis equals 0. You're gonna see this axis command come up quite a bit. Axis is either the rows or the columns. And it turns out, matrices are always organized in rows and columns. So if the axis is 0, you're saying drop the row. If you said the axis was 1, you drop the column. Not understanding how that works is a source of error. You can also just fill them with zeros, that's not done. Okay, data transformation. Okay, so now, he does teach this here. So let's just, I had a question about the standard scaler, so let's just see, we're back in the game here, okay.
Will you share that link, the GitHub link?
Yeah, you can actually, I'll show you how to, that's actually a good point. What does the standard scaler do? A second. Okay, so I guess the standard was the giveaway. It is creating z-scores. So it takes every x, subtracts the mean of that. These will be columns, the 1 month, let's say, and then divide by the standard deviation of that column. And the primary reason for rescaling, it'll tell you this, why is this necessary for PCA? PCA is a variance maximizer. Just make this a little bit bigger. By the way, you can open this notebook, of course. It's one of the ones I gave you, I think in the second email. Without scaling, your analysis would be fundamentally flawed for 2 different reasons. And you can read up on this, but the basic reasons is, if you don't rescale them, then numbers that are big have a lot of influence on the results. Because there's some kind of error, like you're creating an algorithm which is going to be trying to predict what happens when you leave out some of the data. And it measures a prediction error in some way. If you measure in dollar terms, let's just say Apple's trading at $500 a share, and let's say NVIDIA is trading at $100 a share. They're both about the same size company, but Apple's price, because of the way they've split the stock, at 500 would have 5 times as much influence on the error as NVIDIA at 100. You don't want that, so that's why you standardize. Okay. So in terms of the book, right? So this is the book, right? So let's say I want to machine learning for data. If you Google that title and then type GitHub, it'll bring you right in there. So machine learning and data science blueprints for finance, and you'll have the GitHub link. I've also, in the first email with the zip file, I gave all of the notebooks for chapters 7, 8, and 9, which are particularly relevant for our next couple of weeks. That'll bring you to this page here. Okay, and a thing to do, right? So this is, how do I learn, right? How do I learn what's going on? You learn from a book, right? But by once you have the idea of what we're trying to do, and you want to learn how the code works or learn why the code does what it does, then this is the perfect reason to go to your LLM and say, well, what does the standard scaler do? And it's like, here you go. This is what it is. Now, in the old days, i.e. 2 years ago, you could go to sklearn manual page, they used to call them man page, I forget what they call them. Hold on a second, the docs page, right? The doc. You go to the sklearn docs on the internet. Obviously, 25 years the internet's been, 28 years, 30 years been around in widespread use. It got a good description of what this thing does, but you'd have to read the whole page for you to figure out what's going on. Whereas you talk to Gemini, it's like, Here, simple, right? It's very fast, okay? All right, so what do we do here? So we import the standard scalar, and then this is the way that sklearn models work, as I told you last week. And we're gonna go back to the code in PyCharm, by the way, too, but I wanted to come up with this conundrum for you. So this line here says, I'm going to create a variable, I'm gonna create an object, I'm gonna give it the name scalar. That's the left-hand side, okay? Over here, say, take that standard scalar method, which I imported up above. You don't have to give it any arguments. But what happens when you get to the first piece is what's called, you're accessing the constructor of the standard scalar class. Anytime you see a class name with a parentheses after it, whether there's arguments or not, you're instantiating a object of that class type. We'll come up with this again when we go back to our pie chart. And
The reverse in R?
what's that?
Is the reverse in R? Maybe I'm thinking about it incorrectly.
I can't say, but purge whatever that thought is from your mind. Because we're not in R now, we don't want to confuse ourselves. Now, every main object that does these machine learning algorithms that are provided by the sklearn dataset will have a fit method, and it will have a transform method. And it actually also will have a fit transform method, so they do both at the same time. So the way this works is, the object is instantiated, and then you have it, and then it has a fit method, which you call, and you pass the data. So fitting just means this model does something, which in our case, we said would be to compute the means and the standard deviations, okay? And then once we know those means and standard deviations, we've stored them in scalar. We create a new rescaled data set. And what is this argument telling us? It says, create a pandas data frame. This is the constructor of the pandas data frame. And the way you construct a pandas data frame is you give it the data that you want. And you can see the first argument says, the data is going to be equal to scalar.fit transform data set. So I suspect the first line didn't really need to have the fit argument, because we're actually going to go ahead and fit and transform the data in one shot here. So I think this particular piece probably wasted. And then we set the columns equal to the data set that we started with, the columns names. We get another, what we're doing there, this is where you kind of want to poke a little bit. You don't necessarily have to learn how to write everything all the time, but it's good to at least think about, well, what's going on here, right? I can pull tons of notebooks from the internet. Any book that I can think of probably got a GitHub repository. I can get a lot of that knowledge basically for free. But so what is this dataset.com? It's just a list of the columns, and it tells you it's an index, which is a pandas data type, and it's got those names. And then it says the index equal to the dataset dot index. Okay, so let's see what the dataset dot index is. By the way the notebook works, you probably already know this, but is whatever you type last, it executes it and prints it out. And the date time, so the index of the data set is this set of dates. It's called the date time index, which is Panda's way of remembering that these are not just what's an index? Index is the list of, it's the names of the rows essentially, okay? And this says this is a special index, which is that it specifically consists of date times, which means there are actually timestamps associated with this, even though you don't see them, so they'll be by default 00:00:00:00. It's a date time 64. I'm not even sure what NS means. It possibly means nanoseconds, but I'm not really sure. Length of 6150, frequency was equal to none. Okay. So the rescaled data set takes the pandas data frame, does the fit transform, and now we get, this is the rescaled data set. So now you can see that the 1 month in this is 1.086. I'm going to get rid of this here.
What are you running this in? It looks like you're online.
Yeah, so
Jupyter
let me
Notebook.
explain that to you in a second.
Okay.
Good question. But let's go back to the original data set. Data set dot head 2. Okay, so you can see the real data, the first data point had 1 month rates at 367 and so on. The transformed data set, which is all the column-wise means have been subtracted and divided by the standard deviation, is equal to this, okay? So you can see this probably, I'm pretty sure this won't be purely proportional, because there's a nonlinear piece to it. We're subtracting the mean, but then we're dividing by the standard deviation. And the standard deviation of each column will be different. So how am I running this? I opened up, in your case, it would be an Anaconda prompt. Let me just, I ran a command called Jupyter Notebook, okay? And you can do this in your Anaconda prompt, okay? And what that does is it fires, Jupyter is a organization for Julia, Python, and R. Julia is another language like R and Python that was created in MIT to be a much faster Python. It is no doubt a very fast language, just has not yet seized market share in the same way that Python and R have. Okay, and when you run that, well, let's just hit what it does. It opens up a window on your browser, so it uses the browser as the interface. You can see what it tells you here. It tells you some stuff in the background. When you call its notebook function, it says, I'm doing a bunch of stuff, I'm doing a bunch of other stuff, and then it says, I'm gonna run my server at localhost, which is just my machine, port number 8889. It would probably be 8888, but I've already got one instance of Jupyter running. And use Control-C to stop this, okay? And we close that thing down. And I need this one more, okay? And back over here. And key feature when you're launching Jupyter Notebooks, try to always launch it from the directory that has the stuff you want to work on, because if not, you have to kind of navigate this weird tree that doesn't work like most
And
good.
these were all in the zip file that you sent?
Yes, these are all in the zip file. Yes, this is actually probably the second set of email. Let me see. Here.
Because I know you sent that and then somebody else.
Yeah, I guess that was all. Yeah, so those are all in the zip file. The more stuff is the it's just data. There's one more. The more stuff is just the notebook we're working on right now, and the two data files are potentially of interest. Okay, so let's close this one. This right. Command that in there. Okay, so we've got our data transformed, and then he got, you know what? He said, let me take a look at that picture, and it's a different picture, but it's going to be similar to the first one. Okay, now, step 5, evaluate algorithms and models. So the model evaluation, I don't know why it's 5.2 instead of 5.1, but so be it. As the next step, we create a function. So now, PCA with little letters is going to be an object of type PCA, which is we imported up above. And again, this is the constructor of the PCA. And then the so-called, we take PCA and we fit the rescaled data set, which was part of the lesson, right? Which is that you should scale your data before you do your PCA, okay? And assign that to a variable called principal component. It's pretty uncommon to use capital letters when naming Python variables. Much more common would have been to call this little p principal underbar little c component, like so. This is called, this thing up here is called camel case. And there are two kinds of camel case. Sometimes they don't, like I said, run that code yet. Sometimes they don't put the first one, and sometimes capital, so another way of this, like this. This is also a camel case. There's probably some name for whether you capitalize the first one. And then this is what's called snake case, which is normally how you name Python variables. And it's called snake case because, you know, the snake is slithering along on its belly, as it's been destined to do from time immemorial, okay? Now I'm just gonna go ahead and run the whole notebook. So, uncertainty. By the way, when you get a notebook from a repository, well, I like to do this a lot, which is I hit kernel, restart and run all cells. It'll run all the cells, unless you're doing some kind of intensive, deep neural network, which is a very time-consuming process. This is a good thing to do because it runs all your code, and it gets to the, normally, well, let me try it again. If you watch that last bar, you'll see an asterisk will appear, a star. And the star means it hasn't executed this cell yet. And then it crashed, so this means somewhere up here, it saw something it didn't like. I have this problem where for some reason my Jupyter no longer lets me scroll when it's had a failure. But I know where the failure is going to be, because we created the failure ourselves. The failure is undoubtedly.
So now as you're running, what are you looking for that? Are you looking for the red boxes?
Yeah, no, I knew that this was, yeah, right.
Okay.
I knew that I had made these names and didn't really ever use them. Because this notebook should run, that's like what I was doing before I sent them out to you. It take a few seconds, it'll get to the bottom, and now when it gets to the bottom, I'm like, okay, great. I could use this notebook and I can read it and I can understand it. Otherwise, there's a problem, I gotta go look, what's the problem? A lot of times the problem will be that I don't have the library, so I just do a pip install. There's a lot of different things can go wrong. Or some of the code has changed what's in my current version of Python. So there's our rescaled data. Okay, so we're applying the principal component analysis. So we have here, we created a PCA, we created the we found the principal components, and in this step he says, I'm gonna make some plots, I'm gonna create a pandas series, and the series is gonna consist of the explained variance ratio up to the number of eigenvalues. I think number of eigenvalues currently we're setting equal to 5. Now how many eigenvalues and eigenvectors will there be? There'll be as many as there are columns in the data set. So there are 10 columns in our data set, so there are 10 principal components, there are 10 eigenvalues, but we only focus on the first 5. And you can see here, before we talk about how the code does it, you can see here that we're reading here that the first principal component captures 85% of the data. And the next one, the cumulative variance is up to 98.6. And then the third one gets us up to 99.77, 90, 94. So as I predicted, as I expected, I should say, we get 3 principal components, 0, 1, and 2 is the numbering scheme in most computer science language, right? We get to 99.77. That's not what we saw in our code. Now, and remember, first, as a quantitative analyst, right, or a risk analyst, or whatever function you're serving, any kind of analysis in a financial services context or any other context, for that matter, if you have 2 results that don't conform to each other, you have to ask yourself why. Why is this wrong? Now we said, as I said last week, the numbers didn't look like what I thought they would look like, so I was kind of surprised, but I didn't have time last week to investigate. Now I pop open this notebook, which conforms to what I normally think is supposed to happen here. That's going to be this week's homework assignment, which is this notebook gets what I think is the right answer. The Python code I gave you seems to have some error in it that generates numbers that are similar and have a story that you can explain, but are probably wrong in some way. And this,
You have to diagnose that.
that's right. Well, I should say you want to diagnose that.
Yes.
It's actually a good problem, because I have a decent idea what the problem's gonna be. In fact, we've probably already spoken about it this evening. Okay, but I won't give you a hint until you've had at least Saturday. If you want a hint, I'll give you a hint on Sunday. You just email me and I'll write back. But this is a typical. This is kind of highlights a different thing, right? Which is that I've got code that works. It works very nice, that Python code. It does nice stuff, it makes nice pictures. And it generates results which are plausible, but I suspect might be wrong. Now, if the results had been a little closer to correct, I might not have noticed, which is a different question you face. How do I know, to the best of my ability, that the numbers I'm generating are correct? There are lots of different ways that you can make small mistakes that give you incorrect numbers, and you don't see them because you don't analyze. The thing about, Gemini, I wrote all of that code, that whole 8 files. I probably wrote the whole thing in like 2 hours or something, because I just kept saying, do this, do that, and here's more code, clean it up, put it into classes, and it all comes along. But does come a point where we have to look at what I'm getting and say, okay, how do I have the confidence to invest in this idea? Or do I have to be worried? One way it would happen in a business firm, well, one way it happens in a computer science context, let's say, is people check each other's code. Like if you want to put your code into the company's code base, probably 1 or even 2 other developers will do what's called a code review. They're going to review your code line by line, first of all, just to make sure that you just conform to the basic standards that the company wants. Second, to confirm that what you're doing is correct. At least as far as I can tell, I've read your code, I believe it does what you say it does accurately, and you've built tests behind the scenes that will exist into the future, so that if anybody else changes your code, it should break your code. They will also fail tests. The way a computer science thing works is you always create tests for the code you've written, and whenever you want to make a new check-in to the code repository, all the tests have to pass, because those tests were written in the past when this code was working. So if this code's failing now, you've done something, you've broken our code, which is called a breaking change, and that's bad news. But the third thing has to be, do I think this really works? Now, if this is something that is really mission critical, whether you're going to put a lot of money behind the idea or you're going to put the safety of human beings behind the code you've written, you've got to really be sure, which means you'll probably have somebody else do the work as well, and you'll compare your results and see what's going on. Okay, so, and in this case, I had evidence that Gemini probably has a mistake, or at least did not execute the code, in the algorithm the way I intended to be executed, and I'm gonna need to go figure that out. And first thing you should ask, are we using the exact same data in this notebook as in the PyCharm? The answer is yes. I copied the data from the PyCharm here. So there's no question it's the same data. Even up above, in theory, I could have used Quandl to pull new data in. It should be exactly the same data, albeit with one extra tenor, the 6-month tenor. That would, of course, change the analysis slightly, but I got rid of the 6-month tenor. I just used our data. And, because we're pulling, I used Fred to get the data in the CSV, and this notebook proposed using Fred. That would be a pretty good sign that they're probably using the same data, but even then, you'd have to check. Can I look at the 2 data files and see, are they identical? Okay, so we get this PCA analysis. So what do we see here? So we find out that a lot of the variance is explained by the first principal component. It's like 84.87. Some of it is explained by the second principal component. Looks like that's about 15%, and which is kind of interesting. In the past, I have certainly seen number 0 be worth 90%, number 1 be worth like 7%. And this could be reflective of some of what we went through in the coronavirus, plus some of the 0 rate periods of post-global financial crisis. And you want to, these are things to think about. I was actually surprised. I was working at GE Capital with Professor McDonald, and one of my colleagues was doing a PCA on our rates, US rates, but also Euro and Yen rates simultaneously. So all 3 were being fit. And then you find, or maybe let's start with, he did Yen rates separately, let's say. And I found the PCs in Yen were different, 60, 30, 10, or 60, you needed 4 or 5 of them. And that's because that market is different than the US rate market, right? And that was good, good to know. The basic intuition, which is that this is the general level of interest rates, this is the tilt between 2-year and 10-year, and then this is the 2-year, 5-year, 10-year butterfly. These are good intuitions, but they're not necessarily uniformly expressed in every single interest rate market in the world. Okay? And you know, if you have the stomach for it, you can go through how these lines of code produce these tables. And if you don't want to hurt your brain so much, you just ask Gemini, how does this code do this? And it'll tell you what the little pieces do. It says it takes the eigenvalues, sorts them by their relative size, I guess. Oh. And then plots the bar graph and gives it a name. Okay, but you can ask, okay? And now we get a better picture. These are the weightings. So now what this is, these are called the principal components. So what's happened here? You know, let me see if I can graph the. Let me see here. What I want to do here is let me put the cell up here. Let's just see principal components. Not defined. Component. That's a little weird. They left off the S in the book, but that's the way it goes. Let's just ask Gemini. How can I see?
It looks like they started the index at 1 instead of 0 on the cell beneath where you were.
What's that?
On the cell beneath where you were looking at it, the index started at 1 instead of 0, and that may be why it didn't do the short rate.
And hold on a second. Let's see. Components. One second. Let's see what this looks like. What are we looking at here?
I'll go scroll down. You see right there where they set the range at 1 instead of 0? That may be where you only have the pictures of the 1.
Hold on a second. Where do you see the one?
Scroll up. It's right the range there where it says in the range of instead of I in the range of 1 instead of 0.
Oh, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still get small. So what is it just, they're just changing the index there, but I don't know where the index is being, I guess what this command is doing, it says, the normal index is gonna go from 0
Yeah.
to n minus 1, but for the purposes of this plot function, apparently, we need to, reassign its index to be 1 to n plus 1. That must be what that line of code does. I'm guessing if we don't do that, let's just see what happens. One, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it still looks it's the same, so I don't know why it needs that. I'm gonna leave it in for now. But let's go up here. Notice it puts these little things that let you pop a cell in or pop one below. Let's see if that code works here. Now, what's our data frame called? It's equal to, let's just try this. Returns our thing is called, new scale data set. Yeah, so what happens when you do the principal component analysis is, I'm gonna show them all. So it takes that, and let's just put right below it, let's just put, so what's happened here is that Right, so what's happened here is that the original data had these numbers which looked like ones, and a lot of ones, 0.9 and stuff. And these ten column vectors have been transformed through the principal component algorithm in linear algebra into 10 new column vectors, which represents the it essentially represents the correlation matrix of the original data. So we take every column here and correlate it with every other one. So we get a 10 by 10 matrix, right? Because we have 10 columns, so the correlation matrix would be 10 by 10. And it re-expresses them as weights. And what this shows you is that the real information contained in the 6,000 rows can be, which would still give us a 10 by 10 correlation matrix. I guess we had correlation right up here, right? So this is the original correlation. Let me see if I can, maybe I should put this instead. Yeah. This is a better thing for us to look at, comparison. Okay, so the original correlation matrix looks like this. You can see it's not really a 1 in the 1 month or 3 months, 99.7. Okay, so every correlation matrix, of course, has 1 of the diagonals. So the principal components analysis does something related to taking this correlation matrix. It's actually the correlation matrix of the data set times itself. And well, actually, that's what this is too, I should say. And it re-expresses it as finding the principal directions, right? We talked about this in terms of the picture last week, where we had this data set which was kind of lining up on a diagonal line, and the original XY axes have the normal orientation, but the principal components rotate the axes so that they line up along the main direction, which is was our diagonal line in that data set last week. And then the second direction is just the perpendicular to the first direction. And the reason why it's perpendicular is to make the 2 dimensions independent of each other. That's kind of the principal components process. And when we do 3 dimensions, we build the first dimension as the main direction of the data, and then the second direction is the second main direction of the data. That gives us a plane through the 3 dimensions. And then the third dimension, of course, will just be a perpendicular sticking out of that. This goes on, in this case, for 10 different cases. And what you look at here, if you look at the size of this is what the graph is going to give us, but let's look at it as numbers. Look at PC0. All of the numbers are positive numbers. That's the first thing. And they are approximately the same size. They're all about 0.30. Some are a little bit bigger, some are a little bit smaller. And it's also, these are normalized, which means that if you take every number in row 1 and square it, and then add them all up, you will get 1. That's what normalized means, okay? That's the length of the vector. We talked about this last week with the, what does normalization mean? See if my pen's got juice in it. Okay, it does. Switching here for a second. Turn off the Okay, so, you know, we have a, okay, so we have, you know, we have a vector. I guess I'll make this 4, 3, 5, right? So the length of this vector is 5 units, you know, it's the Pythagorean theorem, right? But the normalized version is we divide the 4 by the 5, we divide the 3 by the 5, and we divide the 5 by the 5. And of course, that's what it means to normalize this vector, okay? So in the principal components case, where we had all those numbers, if you square them, and see here in this case, you go 3/5 squared, right, plus 4/5 squared is equal to 25 over 25, which is 1, okay? And that's what it means to normalize a vector. This vector, which consists of 4/5 on this axis and 3, it points exactly the same way as the original vector. It's just reduced in size to be only 1. And it's important that you normalize the vectors, and the principal component algorithm takes care of that for us, so we don't have to worry about it. Okay, now, guess we're due for a break in a few minutes. Not yet. All right, so back over here. Okay, so we're looking at the first 3 graphs here, and this is where the interpretations come. What this says is that all of the tenors in the data set have this positive exposure to the first factor. That's why this was interpreted as the level, which is when the first factor moves, everything responds the same way. They either all go up if it's a shock in the positive direction, or they all go down if it's a shock in the second direction. For the second principal component, you can see why they call this the 2-year, 10-year, or the 1-month, 30-year if you prefer. You can see that when the second principal component gets a shock, the tenors move in opposite directions. This one goes down and that one goes up, or vice versa, so that's why it's called the tilt. And then in the third principal component, you can see that this is called the butterfly. A butterfly trade in the context of interest rate markets is when you buy the 2 ends of the barbell and you sell the one in the middle, or vice versa. And the Zoom watch is telling me that my son's outside. Okay, good to know. All right, so that's that. And then we also get this picture, just a different way of looking at the graphs. And again, you can see, right? And you know, if you work on a trading desk or in a trading firm, they'll talk about these things, and these shapes will have become familiar to the practitioners, right? And this is basically a parallel shift. This one is a shift from the front to the back, and this one is the middle moving differently than the ends. And then finally, we're not going to do this, this isn't that important, but the point here is you can rebuild the original data set from the principal components. And what they do here, they talk about the matrix multiplication. Mechanically, PCA is just the matrix multiplication. The new values Y is X times W. X is the input data, and W is the matrix of coefficients. The only trick of here is your matrix of coefficients is quite special. Okay, I'm not going to worry about that right now. We're not teaching linear algebra in this specific class. They reconstruct the data set. Now, if you use all of the principal components, you'll get back the exact set of data. So it's just a matrix decomposition that creates the principal components. A different composition unwinds that transaction. And you end up, much like, 3 times 5 equals 15. 15 divided by 3 is 5. Gets you back to where you started, right? So you can rebuild your data set. But what will happen instead is when you do this work, you're going to say, I'm not going to use all 10 principal components. I really wanna understand how my book is exposed to the three primary factors: the level, the slope, and the butterfly. And consequently, we lose a little bit of information. We can see in this case, we lose very little, like 0.02 or something like that. But in other contexts, like the equities we were looking at last week, we see a different, we lose more information by cutting off principal components, and you'll have to take that into your analysis, okay? All right, let's take a break right now, and we'll pick it up at 5 to 8 or so, okay? And then in the second half, I'm gonna go back to the PyCharm, mostly because I wanna just talk you through how the code works, how the IDE works, and maybe we might even get a hint as to where the code is wrong. But anyway, the code itself works, it just doesn't do exactly what we want. We should be able to fix it. We're using all the same Python commands. That's clearly not true because we're getting different answers. That would be that's how you find the mistake, right? What does this do that doesn't do? And then you have two versions of the answer, and you have to ask yourself, okay, well, which one of these is right? Right? And my guess will be that the book is probably right because the author is smarter than GPT in this one little subset of information. Okay, let's take a break.
care how to run whatever files you're giving. 'Cause
Yes.
I guess my,
So, oh yeah, so what you should do is you could take the 3 that came through at the end. Second email, right?
the 2XLs and the
Yeah.
yield construction.
Drop them into the folder that has the project you're already working on for
The Python.
whatever you
the
made for Python. Just
Yeah.
create something, call it like PCA, let's say. Just drop them in there. Do that, and I'll be right back. And I'll show you how, and get your Anaconda prompt up. Mr. Reed, you look like a new man.
Well, you see, this is the name of the book that you sent out. Deep Learning and Quantitative Trading.
Oh, yeah, okay.
UConn has access to it, so you don't have to worry about it being free.
Okay. It was free at that time
Yeah.
too. I have to pull that book up again. Look at you, got it. Yeah. I downloaded a different book today. Giuseppe Paleologo's. Look him up. Paleologo. He's got 2 books. He had one out in 2021. He's written a new one. He's really famous. I don't know him that much about him personally, but he's working now. He's like the head of something at Baliosity, but he's been at like Hudson River Trading. He was at Citadel. He's got a illustrious career.
PAL.
Yeah, EO space. No, LO, sorry. LOGO. No, you're missing LO. PALE, paleo, and then logo.
Oh, I screwed it up.
Put a logo instead of just go. LO before, yep, right there. There you go. Gappy, it came up. Look, Gappy. Yeah, that's one of the 2 books. The new one is his other book. Go back and it'll come up too. Or actually, you can click on Amazon. Yeah. Go right click again. Go forward again. No, just go forward. Yeah. No, go backward. Yeah. Yeah. Click on that. Well, click on it. Click on that one. It's
I hate these. I didn't bring a mouse with me today. These keypads drive me nuts.
yeah, I can imagine. My Mac keypad is a lot better than my Windows ever was. But just type him in again. Just type Paleolo. It'll come up. There you go. He's already there.
This one?
Yeah. And scroll up a little bit. This is his older one. He's got a newer one, which is, I think, meant, there you can click on Amazon, and then you can click on the author's name. There's the other one. Click on the red one. That's one I ordered a review copy today from Wiley. Looks like a good book.
You should have access to Vital Source too, though.
I have Vital Source,
Yeah.
Wiley's now doing the reader copies through their own little thing. They used to send me Vital Source stuff. The other book is on O'Reilly too. So O'Reilly's got a lot of the Wiley stuff. It just doesn't have all of the O'Reilly stuff. They had advanced portfolio management. The O'Reilly's a good deal. It's like I got it from Georgia Tech. I'm still getting it, but eventually.
Well, they give you as an instructor 100 books a year.
Oh, do they?
Yeah.
I didn't know that.
Once you have instructor status, it's 100 books a year.
Oh, that's a lot. That's pretty good.
They give 2
I
for a
didn't know
year,
that.
but you could renew them at any time.
I didn't know that. Okay, that's good. I'll be right back.
That's good to know.
The course you really want to take is the one he teaches in the summer, the derivatives class. That's where you learn stuff.
When is this class?
In the summer.
In the summer.
Monday nights. It's going to be Monday nights this summer.
Monday nights here.
Yeah.
I might have to get in that class.
I just recruited him for your summer class.
Uh-huh.
I just recruited him for your summer class.
Oh, you did. Very good.
Because that's what will be. Let me see if this is in here.
Oh, so you have instructor status.
Yeah.
Oh, they don't have dynamic hedging anymore?
Oh, I don't know.
That was
Well, that maybe
Nassim
just-
Taleb's book.
Yeah, because I've taught EMS. I've taught anything from EMTs up to paramedics. So that's how I got this like
Ah, good, good.
15 years ago.
Oh, very good. I did not know. They've often given me books when I requested them, and
Well, they got tired of mailing out paramedic books that are this thick that weigh 10 pounds.
Yeah, yeah, and I don't need. I don't like paper books anymore. In fact, I ordered a book, and
Yeah, it's in here.
oh, yeah,
And it looks like it's free too.
yeah.
When it says that, you get it for free.
Okay, good, good.
Come on, will you do something?
But the red one's the one I want to read first.
Maybe I gotta just click on that like that.
Yep.
Why is it not? You essentially have to tell it you gotta wants me to sign in, that's all. With this, it makes you, it lets you only have one account signed in at a time.
Yeah.
Close. Makes you have to tell that you're gonna teach a class in it, that's the whole deal.
Yeah, yeah, yeah.
Yeah. Do that from you, but then it just gives you an email with the link.
Good to know.
There it is right there. Yeah, they never really had rules before, but now they say 100 books a year, and they stay in your library for a year. Then you could
Yeah.
you could renew them.
Yeah. And I've got a couple of vital sources from
Yes, it-
from publishers, but with direct requests to the publishers as opposed to getting them
Yes.
direct from Vital Source. But I think the other book is probably the one to start with.
I'll find it later.
Yeah.
I'll back up later on and find it.
Did you get your prompt?
Yes.
Okay, so let's see. So of course, that's good. Now,
I'm trying to create the PCA environment.
okay.
Isn't that what I'm supposed to do?
No, you don't necessarily need that every time, because you have environments you've already created, right?
Correct.
Is this the one for this class, 53, 52?
Yeah, that's
Yeah,
the
so
one.
hit Control C instead. Say, or just say no. Knows the defaults of the enter. Yeah. So instead do Conda activate. And then FNCP. This environment should work for testing. And if you need libraries that are missing, oh, it might give us problems actually, because the libraries are kind of old. I don't think anything we're doing there will be libraries. Okay, so now you're in, now what you want to do is you want to navigate to wherever you put those files. Because you want to be in that directory when you launch the Jupyter Notebook, otherwise you have to hunt around for it in the interface and it doesn't really work that well.
So I believe I saved its own folder,
Okay, yeah.
but I put it in the environments folder.
Yeah, okay, I would take it out of there, put it in the other code. That's it, all right.
So,
That you don't really want, that's really Anaconda's tweets, then you don't really want to drop stuff there.
Got
You could, but it's not the place for you to do it personally.
I think I put stuff
You
here.
put it right there if you want.
Yeah.
You can even put it in the class, just as part of the class. That's up to you.
I'm gonna leave it
Yeah,
there.
yeah, leave it there. So now go C Python PCA.
See,
Or you just gotta go to you're already here.
oh, I could just
Okay.
take that.
Okay.
I could take all that?
Yeah, there you go. Hit enter. Okay, so you need like quotes around it because it's got spaces in it. So you do up arrow.
Oh, yeah, that's right.
You put a quote at the end and then a quote at the beginning. And that should probably work. So you want to do, let's just do, we're already in C users, J and J, so just do CD doc, do CD space, just, let's see, Control C. CD, right? Type D, space, number space, type D, hit tab. And then, of course, you can see Windows is not case sensitive, I'm not connected to the account. And hit enter, that'll get you there. And then you do CD space, P, Python, P. Tab. Okay, now you can do by DIR, so you can see those files there. Maybe CD PCA. Not so bad if you start from this level. Do one more, CD space PCA. Tab. That looks fine too. Okay, now do DIR. Okay, so you can see that's the notebook we're working on.
Yeah.
So now what you do is you type Jupyter, G-Py, P-Y-T-E-R, Jupyter, space, notebook. Enter. And so Jupyter's not recognized. That means we've never added it to our environment here. So now do pip install Jupyter. That should be enough. Or copy install that. It should be. Let's go around and find that stuff we need.
Is there a reason you do it in Anaconda and not in Python?
Well, Python would, in theory, would be accessing the same Anaconda prompt. But last time we looked at it when we were working together,
Mhm.
I think we were not getting the one that we wanted.
Right.
There's a way to make it happen. We have to just ask, just tell,
I'm an open AI guy.
tell Gemini, tell GPT, just need to,
Yeah, I've officially created my new project, learning Python. So I'm gonna start asking it as many questions as I can.
that's good. I've never created projects, I should do that.
I try to organize
No,
that.
that's good, that's good. Move the second one
Your red book is in Vital Source too.
What was that?
The red book's in Vital Source too, for Ed.
The red books.
We were talking about two things.
Oh,
There's a
okay.
red and
Oh, like full on Matrix, red and the blue pill?
blue. It's also like that,
Yeah, there was a red book and a blue book.
Ah, see, I did the up tab. I did it. Uh-huh. That's thinking a lot.
Okay, it's ready, yeah, so now you do it, and it's a little slow, that's because you just downloaded, it's probably compiling some stuff for the first time.
Mhm.
But it will eventually, it'll hop right into a browser, and the browser will have those three files that are in this sector.
That's doing a lot of stuff.
Yeah, no, okay, click Chrome and say all those. You should-
No, I'm a big fan of that.
Yeah, Edge was trying to get in there, and double click on the wheel construction.
This is fantastic. How do you guys figure this shit? So funny.
That's okay. I did curse with the match too, but okay, so now what you do is you click kernel and say restart and run all cells. Check this box because I do a lot. It always makes you do it every time you do that. And you'll see what happens is it shows you at the bottom, I'm waiting to get here. Right now, I didn't run that command. Since I already cleaned it for us, it should work. But if it fails, that cell will turn blank and then there's mistakes.
And then I gotta go.
Hunt it down and fix it.
Got it. And then I would compare this to what we did in PyCharm. And
Yes, and you'll be able to, at some point, figure out what went wrong.
interesting.
If you look at the code line by line, you'll probably see something different.
It could be two different ways of doing the exact same thing, but I think there's one step that's probably missing in the pie chart.
There was a lot of hand-holding last week when he was helping me step through this stuff.
There's a graphical way to get into Jupyter too, that's very easy, if you haven't figured it out yet.
Maybe you message me and let me know.
I'll just stop by here before you go home.
Okay.
let's start again. So if you haven't taken advantage of the time that I've offered for one-on-one sessions, I did, like I said, I did it with 2 students, and they both found it useful. If you're comfortable running PyCharm by yourself, I'm happy for that for you. I'm not trying to push my services onto you, but I do have time right now that I think is useful. And let's go through how this works in PyCharm. And so the thing about the PyCharm environment, or any other integrated development environment, is that it provides lots of useful tools in one space, in a way that if you've studied Python and you've only worked with Jupyter Notebooks, you don't really get the same experience. Jupyter Notebooks are good too. They are useful. You can actually see what's going on in Python, but if you have problems, you can't really see what they are. One of the things you get over here, this is called I guess I call it the page tree. I don't know if that's the right word, but you can see this little folder on the top here. You make it go away, you make it come back. So this is a good way for you to see the whole project. Now you can see what's going on, right? Working with the Jupyter Notebook, one notebook at a time, is useful. But I've got 10 files here. I've got data. I've got other stuff that I've been doing all year long. That's why I called this Quant Code 2026. I got a lot of stuff here. And if I work on if you work in a company where you're going to participate in a coding way, now you don't have to be a coder. You could be people on the risk desk, for example, would be a good example of people who aren't necessarily professional coders, but they do sophisticated analyses in Python, and they will have a repo which consists of shared code between different parts of the team. And you'll also maybe have a personal repo where stuff that you do, you keep it in one place. And PyCharm is a great way to see all of that and to mix and match stuff. This over here is obviously, these are code files, right? Down here is a console window, which is like your Anaconda prompt shell on Windows, or your terminal window on a Mac. You can actually access these things over here. You'll learn more. The reason why I like JetBrains, which the maker of PyCharm, is all of their IDEs work the same. They have top-notch IDEs for C#, C++. WebStorm is for like JavaScript and TypeScript. They've got something that I have never really used that much, but it's called DataStorm, I think, or Data something, which is all about talking to databases. And I didn't get into that one that much, but and all of the interfaces share a similar look and feel. Their original product was a Java product, and the one command that's always critical is getting to this settings box here. And this is where you control the Python environment. Much like at a command line, we create a Python environment and we activate it. This tells me that for this Quant Code 26, I've got this Python interpreter. It's stored at user local bin. That's where it is. That's where the Python piece is. And it's got all these packages in here. I can go see them. I can install them. One of the things you get, if you're looking for a library and you try to run your code and it fails because the library is not there, PyCharm will offer you the ability to just click a button and it will install it for you. The other thing you get from a good IDE is you get these little line 13. You see this little squiggly. It's telling me, I have an issue with this. So you hover your mouse. It's not, and it says, oh, it's just a typo. It likes to tell you if you have typos. Code bases that have like normal words spelled incorrectly are kind of annoying, and people do live with them. But Yukon happens to be normally I'll go more actions. I'm going to say, save Yukon to the dictionary, and it's no longer a problem. Sometimes even when you tell it, it's not a problem. It continues to work, but that's okay. So, but I want to talk. Let's talk more about the one particular code that we wrote here. Let's start with this concept of the data class. So, one of the things that you get when you start writing code in files and saving them for yourselves, and then looking at them from an IDE, but you can do this without an IDE, but this is the best, is you start writing classes, right? And the fundamental paradigm in computer science since 1980 has been the class, or what's called, I should say, has been the object-oriented programming. There were other paradigms for programming, the C language, which was really the star between 1970 and 1980, and is still like the second most used language, didn't have classes. C++ was created to be C plus classes. That was essentially what it was. And what is a class? And what happened was people had this concept of a class in the 60s. They didn't really, the 1960s, that is, for those of you who may not have the same timescale perspective as I have. But people in the 60s, they started to recognize that as they wrote more complicated programs, that they needed to develop an intellectual framework for organizing what they were doing. And one of the things they came to understand was a problem with C, was that C kept data and functions separate. The basic way C worked is you assign values to a bunch of data, you might have read it in from somewhere, and then you took that data and you shipped it off into functions, and the functions did whatever, and usually sent you some stuff back, like answers that you're looking for. What they started to realize, and what was underlying class object-oriented programming, is that it makes more sense for a complicated system to have what are called objects. And the point of objects is they're supposed to model things in the real world. So for example, let's say you're going to create a traffic flow system for trying to figure out where we should add a new exit or a new lane of highway to understand how things are going to work. Or how should we set up the traffic lights in order to make pedestrians safer and improve the flow of traffic through New York City, right? Well, what will happen if I change X number of neighborhoods in New York City from 25 miles an hour to 20 miles an hour, which is going to happen actually now. What will that do to traffic flow, right? Well, you need a system that models this. And the fundamental idea of object-oriented programming is all of the things that are in that environment should be their own object. So a traffic signal would be an object, a car would be an object, a pedestrian would be an object, a street would be an object, a traffic law would be an object, a sign would be an object. And most of the times when you create objects, you also give what is an object? Object is basically a set of data. So if it's a student record, I need his ID, his address, his phone number, his current number of credits earned. And then there'll be methods that will act on that data. Like, give me the student's GPA. Well, I've got his grades, I've got a formula, I send the grades off to that method, I get back the GPA. So, and the real breakthrough is that you could not change the data unless you were a method that was associated with that object, with that object. Now, the paradigm, and the way in which this paradigm is expressed is through what's called a class. And what a class is, and the word class in line 7 is that it's called a reserve word, that's why it's in orange on the screen there. A class is a template, which just means it's basically a machine for creating objects. So anytime I want a class of the type treasury config, I just call the constructor of the class and say, give me one of these. And I could have 10 of these running at the same time if I wanted to in my program. Each one would have its own data, okay? Let me show you a different class first, we'll come back to this one. So if we look at the most interesting class in this project, it was, let me just, notice what else you get. So a couple of things you get from IDEs. You get all this cool color coding that helps you to understand and visually organize what's going on in your program. But I get this little drop-down arrow, and I can just collapse all that code, so I don't want to look at that right now. What I want to look at right now is my class called the PCA Analyzer. So what this means is, like in a single program, I might decide I'm going to analyze European rates, I'm going to analyze Chinese rates, I'm going to analyze Indian rates, I'm going to analyze Japanese rates, I'm going to analyze US rates. I could create 5 different PCA analyzers, and they could all independently work. And how do they do this? Well, each one of them gets the type of data that belongs to a PCA analyzer. That name is mine. So there are, Python itself comes with some core classes. An integer is a class that has things that can work. These are given to you by Python. Other libraries bring their own classes. Pandas brings in the data frame and the series. NumPy brings in the ND array, which is n-dimensional matrix. You could have anywhere from 0 to 100 elements in your, dimensions in your matrix, right? But this is my class. Gemini made it for me, but it's in my code base, so it's mine. And the first thing you'll see, almost every class will have what's called a init function. Sometimes Pythonistas, as they're known, refer to this double underscore init, double underscore. They call that dunder init. I never found that logic particularly, that wording particularly attractive, so I never say dunder init. I just say init, and I know what I'm talking about. But the double underscores are Python's way of telling people who see this code, this is a very special method, you should probably not mess with it if it's not yours. And other languages have different ways of stopping people from messing with something like the init. But this one,
Are there other unique double under functions?
yes,
like
every
this?
class will have its own init function. The init function is called the constructor. And what happens, and we saw, let's just go down, here's another thing you get from an IDE. You see that this class, PCA Analyzer, is only being used one time in my project. But if this was a big code base, it might be used 15 times. I can just click here and say, where is it being used? Well, since it's only got one place, it brings me right to it. If there were 2 places, it would pop up the list, and I'd pick one. So we see what happens here is I create an analyzer, I'm calling it, called the PCA Analyzer. And I give it raw data frame. We saw a code in the notebooks, my PCA equals, we saw something like this in the notebook, right? And notice this PCA didn't take any arguments. This was calling the constructor of the PCA class inside of sklearn. What I'm doing here is I am calling the constructor of my PCA Analyzer. My PCA Analyzer apparently either requires or at least allows you to send something in. I'm sending in the raw data frame. Now notice this little trick here. I put my cursor in the word, and then I right click, it brings up context action, then I say, go to the implementation. I want to see this thing. So I pop up to the implementation, and I'm back where I started. This is one of the things you get out of the IDE. Okay? So the initiator takes a data frame. Now, this thing here, I'm just going to do the following. Okay, the hashtag in Python means everything after the hashtag should be ignored. It's just a comment. That's why it turns gray. You're allowed to have it there. I might say this class, you can see this line 60 is a different type of comment. It's the comment you put with a class, but my comment that it performs PCA and generates visual, okay, very good. But notice that data doesn't really require this colon pandas data frame. Python is what's known as a typeless language, which means that you can pass any type of data to any function, and Python will try to make it work. Other languages, C#, C++ come to mind. If you try to send the wrong type of information, like if it's expecting a floating point number and you send an integer, or if it's expecting a data frame and you send a vector, it will not compile. You can't even run the code. Python will let you try to run it. Like, so for example, I'm gonna put a little breakpoint right here. And what I'm gonna do, I'm gonna right click, and I'm gonna say, go ahead and debug Fred, PCA Fred v2. And, okay. So it gets up to this line of code. So what happens here, over here I have a window called the thread window. I've got this is called threads and variables. Over here, these are threads. Over here, these are codes. Now, we'll only work with one thread at a time. Multi-threaded programming is when you have your program doing several things at one time, and the operating system controls which thread is getting attention. We'll only write one code. But notice it says, I'm in this line 62 of Fred, but I can click down here, and it'll take me back and says, I came from here. I came from line 53. So what happened was, I got here, I'm gonna hit stop now, and I'll show you again. So I can right-click, hit debug, and what happens with debug, notice I put a red breakpoint at line 153. The breakpoint just says, stop running the code, and let me take a look. So I'm gonna go ahead and say debug Fred. If I say run, it will just ignore this, it'll just run the code. Okay, so it says, so now what I wanna do is I wanna step in, I wanna say, what happens when I get to this code? This is like how you, A, understand code that you've been given, whether it's from your teammates or from your LLM, or B, look at your own code, trying to figure out why does it not do what I want it to do. And you can see down at the bottom here, look up, right? You can see it's got these, I can step over this function, in which case it'll just try to jump over. But I really want to do this, step into my code, and it goes in. Now, I didn't really have to do this because I already had a breakpoint here, but it says, you can see what happens, it gets data, and I can click over here, and down in the variables window, I can see data, I can view it as a data frame, and for some reason this has stopped working for me. I'm gonna have to reinstall PyCharm probably. It's supposed to show me the data. No, why is that not happening? It was being done in a different way, let's see. Table could not be loaded. Yeah, this thing got messed up. This is just a recent event. I'm sorry about that, but say hello to me. I did it with the students, it was still working fine. But what I would see, I can tell you what I would see, is I would open this thing up, it would actually show me this, except for being a little pretty, this is the data that I pulled in. It would be in a pretty format that had colors that said blue is low numbers, red is high numbers or something, which can be useful. And the point is, you want to be able to look at your data and say, or look at your variables. When I have a mistake and I can't realize why the mistake is happening, let me look at what's going on and say, oh my God, I expected that this would be 5 times 50 and it's just 50. I can say, well, I missed that 5. Somewhere along the lines, I was expecting it was gonna multiply and I didn't do it, right? Okay. So what happens when you call when you call the PCA Analyzer class, like we did down below, over here, right? And you give it information, it goes to the constructor. And what happens in the constructor, it says, just take that data and stick it into self.raw data. Now the word self is the way that Python keeps track of this specific object. So if somebody else creates, if I create another object when I'm running this code, that object will have a knowledge of itself, which is what data belong to this. So that's what self does here. You always have to put self as the first argument to any method that belongs to this class. And you can see it belongs to the class because you see over here, the class is at character 0 on its own line 59, right? But the def is indented by 4 characters. This def is indented by 4 characters. Over here, this first line of code in run analysis is indented by 4 characters. This was Python's way of showing they use indentations, whereas other languages use braces and parentheses to achieve the same effect. Python, when the guy, Guido von Rossum, created Python, he said, writing all these curly braces is a hassle. I'm just gonna always insist that you indent. At one point, you could set the indent to be either 2 or 4, maybe even some other number if you wanted, but everybody does 4 now, so don't do 4. Don't be antisocial. And plus your code, your teammates will say, we're not gonna approve your code because it's stupid. Why is it stupid? Because you're only indented 2 times, everybody's using 4, what's not okay? HR is supposed to filter out your kind before we get you on the team. So, so all that happens in this, in the init function is the data that I'm gonna use is saved as self.raw. I could have called it self.data. Gemini kept it as raw data, so I went with that, right? And this is a different part of the process. After you write code or receive code from an LLM, you might want to refactor it, which says, makes your sense of what's good programming style more expressed in your code. But, you know, it does write pretty good code. So even if it's got a mistake here that we haven't found yet. Okay? And then these other variables are going to be used down below. I assign them to be none. I could have made self.analysis here none, which just means this variable exists. I don't have a value for it yet. If you don't include that variable in the constructor and you just say define it for the first time down here on line 71, PyCharm will give you a squiggly, a yellow squiggly saying, you know, you're using this thing, but you didn't define it in the init. Like, it's okay if you want to do it, but I don't approve. That's, you know. Yeah.
Is there a limitation on how many selves you can do in the constructor?
There's only one self, but there's 5 different member variables, as they're called. And there's no limit to how many member variables you can
So you
put
can have
there.
100 selves.
You can have 1 million. You can't have more than the number of atoms in the universe.
Got it.
So there's, obviously there are memory limitations, but you would never run into them. But if you had too many things, it would probably be an indication that your class is trying to do too much stuff. And you should probably have subclasses which, keep, you really want to keep the class as tight as possible, but not too tight, okay? So all this does is assign all this stuff. And then what happens when we're done, we have an instance, as it's called, this process of calling the constructor is called instantiation. So remember, a class is a template for an object. When we call the constructor, we instantiate an object of that class, and that's what we're doing here, okay? This would be the kind of thing that would be covered in like Computer Science 1 or maybe Computer Science 2 in that part of a CS program, okay? Classes come in just a little bit later. First, you just learn how to run. So now I can do F8, which just runs the code. F8, and see, it's just doing stuff. Right now, it's doing nothing. And then now it jumped back out. Now notice we're back in the main thread, and there's no sub-threads. And now we go into an F8, and now we go over these. So now I create the loop. I presume you may know what a loop is. If you don't, you're going to need to learn some Python, some more Python. This is general program. This just says I'm going to do 5 different start years, 2000 to 2020. Now this is, of course, this is one place where our code might be different than what's being done in the notebook. The notebook did use all 26 years to generate the PCs of 90, whatever it had, 84, 15. So that might be a reason, but I don't think that's the reason. It would certainly, it's certainly something we're doing differently. I can actually check this out, right? Let's just try this. We can check that out right now. I could say, I could do on the very first one, end year is gonna be 26, I guess. A good thing if you're gonna change code that you really don't wanna change is you make a copy of the code. You can comment this out if you want, you don't have to comment it out. But I'm gonna just do 26 here. And then what I'm gonna put a little breakpoint down here, and I'm just gonna go ahead and I'll put it right here actually. I'm gonna run, I don't need to stop here anymore. I'm gonna right click debug. And you can see it stopped. I don't know why it keeps going back over there. I guess that's the window that it thinks I should be in. And so notice what I did. I don't need to stop here anymore. I already made my point to you. Let's get rid of the breakpoint so I don't have to stop here again. And now I get down here so I can see my start year and year 2026. Okay, so it looks like this will work. I'm just gonna let the code rip from here. Let's see what we get. Oh, I don't need this anymore. I don't need it right now. Okay, so you can see we still get different numbers. We get 70 and 16, so we only get 86. So this is still definitely different. Okay, so we've eliminated.
The other one was 80%.
The other one was 84 and 15, I think.
Mm-hmm.
So there's still something different, and we'll want to check out. I'm going to close you. I think if I close these things, it just keeps popping them up. Except I've got to stop over there. I'm going to stop there. All right. So Control Z, in Mac, Command Z. One of the things I don't like about the Mac. Okay. So now, all right. Let's run the code. Right click, run the code. And it's called debug for a reason, right? It's because I need to understand what my code is doing because I think it has something wrong. Or in this case, Gemini wrote a lot of this code for me. I don't even know what it does. Let me take a look. So notice how this works. I've created this analyzer and I gave it the raw data frame. And the analyzer has a method called run analysis. And that's indicated by this dot operator here. So the dot operator says, take this object and dot, call this method. I could also name one of the variables and I can just get the value of that variable, but because it's followed by parentheses, I can tell it's got it's a method. And what this is telling you, I could have just passed white start year and blue and white end year without the orange ones, because as long as that's the order of the object, of the variables in the method, I'd be in the right place. The point of including the start year equals, what I'm saying is, this variable gets assigned this, and this variable gets assigned this. And in fact, if I hover my mouse over run analysis, well, it tells me it's a method, it doesn't tell me what the arguments are. All right, so now I'm going to F7 into here, and we can see what happens is, it takes a start year, which is an int, and an end year, which is an int, okay? So it takes two integers. And remember, I said, these ints are suggestions, somebody can send something else in, and Python will try to make it work. I didn't show you how that breaks up above, but I'll show you in a second. Okay, so it says, self.net, so it takes this object, and look, down here is the object itself, the self, and we can see what is the self. Self is an object of type PCA analyzer. This particular instance has these variables set.
Constructed.
Yeah, we already constructed it, but notice if I go back down here, I don't have self anymore because I'm not in the method, but I do have analyzer, and it tells you the same thing. Analyzer is an instance of class PCA analyzer, and it's got, I did give it data, and I now have it defined the analysis years as just a string to go from 2000 to 25. And I haven't done any of the filtering or gotten the loadings of the PCA yet, okay? So I go back up to where I am in the code, and then I do this thing. So I want to talk you through some of this just as a lesson, but there's a lot going on that I'm not going to be able to teach you. But a mask is a computer science phrase for saying, I'm going to set, I have this 6,000 rows, and I want to only take the first 5 years. So what I'm going to do is I'm going to create a mask, which will be true if it's the 5 years that I want, false if it's not in the years that I want. And this mask does that. It says, take a look at raw data. It has an index, that's the left-hand column. That index, every element has a year. If the year is greater than the start year and less than the end year, then I'm going to study it in this particular example. So you'll see what happens is I do F8, and now I can take a look at the mask, and you'll see the mask has a lot of truths. That's because we're in the beginning, okay? But what's going to happen, you'll see.
Once you get to 2006.
Yeah, I'm just going to let this thing run until it gets back to the mask, which is the next 5 years. Give it a second. It's running the pictures. I could make these windows not pop up and annoy me, but I haven't. And now I'm gonna run it. You know, look, there's a little 1 arrow here, and it gets back here. Now I look at the mask. Now I take a look at it as an array. You can see there's a lot of falses. So now I'm running 2006. You can see if you hover over here, you can see the start year is 2005 and the end year is 2010. So all of the first rows of data, 2000 and 2004, they're out. They're not in the game anymore. I guess I'm actually doing a little bit of overlap here. I hadn't really thought about it. In the first data set, I ended in 2005. The second one, I started in 2005. So that's kind of imperfect, but all right, now I learned I made a mistake. I did something that I did not intend. And what happens in this line is that the data frame gets filtered. And what filtered means is we're going to apply a rule that says keep or don't keep. And what's going to happen is I'm going to execute this. And now we see that the original data frame had 6,100 rows, right? And the new data frame only has 1,500 rows. That is, I filtered out to only the 5 years that I'm studying in this period, okay? So they weren't completely overlapping. And I've got loadings. This is interesting. I don't think I did the PCA yet. I wonder where these loadings are coming from. Oh, yeah, so this is interesting. I'm reusing this self object on a new set of data. The self object remembers the old loadings and also remembers the old principal components for the 5 years from 00 to 05. I guess it's really 6 years. But we'll see in a second. If the filter data frame is empty, it's not. It does yield change is filtered df.diff, okay, whatever that means. It's kind of probably at the root of where we're getting different answers. The number of components is 10, and I do a PCA. Now, let's see, if you watch here, I'm gonna do the PCA. Well, let me expand the PCA. And let's expand the components, I guess the component. So these components have some values. This is kind of hard to see, but what will happen is, right now I'm just creating a PCA. I didn't do a PCA, but then I fit. And when I fit, all of those things will have changed. And right now the loadings are gonna change. Like you can see the first loading, it's a data frame. I wish I view it as a series. I gotta fix that. I'm sorry about that.
What are loadings?
Loadings are, the principal components have weights that are attached to the 10 different columns. These were the numbers that we saw for the first principal component were 0.3, 0.3, 0.3, all the way across. Second component, some were negative, some were positive. Okay, so when we do this step here, it goes ahead and it's gonna, the loadings will change. Okay, so that's what I wanted to go through with this. There's more to be done here, obviously, but this will get you started. Finally, at the bottom here, I go ahead and I print stuff out. So if I let this thing run until the next round, you may pop over to the other window. And down here, in the bottom, I've got the console. Anything that I've managed to print to the console, it's telling me, this was the results for 2005. That's just because I printed them up above, okay? All right, now, I'm gonna stop there on this. So I do believe, just for what it's worth, Python could unexpected, okay? I do believe for what it's worth, I'm pretty sure we'll find that the main issue, well, the main issue, we know where the main issue really has to be. Why does this give different results than what we get from the notebook? It has to be in these 4 lines of code. Right? There's no way that this, because look, here's where the PCA happens, and here's where the fitting happens. So if I'm calling the same method from sklearn, if I'm fitting on the same yield changes, whatever I call it in the other notebook, it can't be the same thing, because if they were the same thing, they'd get the same results. That's what computing is all about, right? Except for random fluctuations at the quantum level, which can creep in, but are pretty infrequent.
But did you say this notebook was reusing data? This notebook was reusing data too, though?
What's that?
You said this notebook was reusing data too, right?
We're using the exact same data.
But this one was using the endpoints twice.
Well,
right?
no, we did say that the big notebook did use all the data at once, from 2000 to 2026. So we don't expect that any one of these 5-year periods will look exactly like the original notebook. But there's no way they should be at 60, 70% in the first PC. There's gotta be something that's not valid here, okay? And you can go ahead and ask your LLM, I did this, I did that, why am I getting different results? And it will tell you. And then you'll be done for this week's homework. And, but I'll make some coding and homework for you for the next class. So what's gonna happen in the next weeks is, I'll be here 1 more week, and then Professor McDonald will be here on the week of the 8th. That'll be, actually, I guess, what's the date?
24th.
Yeah, so, I guess, yeah, I'll be here on the 31st, Professor McDonald will be here on the 7th, I'll be here on the 14th. Then, the 21st, I'm gonna do 1 class remotely, so I'm gonna be out of town. And then the 28th, which is the last class, Professor McDonald will come back, and we usually have a pizza party for the last class. So, if you like pizza, we'll have pizza. If you don't like pizza, we'll get you something else. And we have a class as well.
To confirm, we're comparing this code to what we were looking at in the yield
That's right.
construction on Jupyter.
Right. The notebook is doing something different with the data than the Python file. The notebook conforms to what we think should be the right answers, you know, at least up to like, you know, these minor errors that we would have to work harder to detect if it has them. But the code file appears to have a significant error in methodology. And it's actually an important issue. And when you discover it, don't tell anybody if you discover it until you get it. if you discover, you'll say, that's interesting. And then you can ponder, well, why is that important? And why should I, why is it done, why is the other way right and not this way right? And that's that'll be a philosophical, mathematical question for you to think about. Okay, so, now along with the yield construction in this chapter, there's a different version, and of course, whatever mistake we're making with the interest rates, it's probably happening with the stocks that we looked at too. And it doesn't maybe jump out as much with the stocks, because the results in a stock market are much more diverse than they are in an interest rate market. So there's a second notebook that I gave out. This is like chapter 7 of the Blueprints book, called Portfolio Management, the Eigen Portfolio. So Eigen refers to principal components, as they're known in this specific context, are eigenvectors as they'd be known in the more general linear algebra context. And the variance that is explained by each principal component is related to the eigenvalues of the original matrix. So just to show you what that means in the context of mathematics, since I have math, I should do some math, right? I used to teach high school once upon a time, and I taught mathematics, and the students would say, what am I ever going to use this for? I said, well, it's hard to say exactly, but I can tell you one thing, if you don't know it, you're not going to use it. And for many, that was like, okay, thank you. Some of them have not only gone on to very happy lives, some of them maybe not. So what an eigenvalue is, I don't wish negative on it, of course. You have a matrix, it's got rows and columns, 1, 5, 7, 3, 2, 1. It only applies to square matrices, okay? This would be A. You know what, let me just scale back my ambition a little bit. Okay, this would be A. And we'll just pick a vector. Let's call it X. So when you take matrix A and multiply it by a vector, what you do, if you've seen this before, is you take one row at a time. So first of all, the matrix A is 2 by 2, 2 rows, 2 columns. What's the dimensions of X? Well, it's 2 rows, 1 column. And it's always the case for this matrix multiplication to be allowed, matrix vector multiplication to be allowed, that the inside dimensions have to match. And that's because what we do is we take the first row and we multiply it by this column. And the multiplication is the so-called dot product. But that means you take 2 times 1, and you take 1 times 1, and then you add it. So 2 times 1 is 1, it's 2, plus 1 is 3, so this is equal to 3. And then you do the same thing, 4 times 1, 4 times 7, that's 11. Okay? So this is equal, this says if you take the vector x, which is, you know what the vector x looks like, right? In the, x is 1, 1, right? So it's 45-degree angle, right? 1, 1, isosceles triangle, right? So this is going to be 45, 45, and 90, right? Okay. So it's the y equals x line. So this says if you take this matrix A and multiply it by multiply the vector 1, 1 by it, you get a new vector 3, 11. So where's 3, 11? So 3, 11 is like here. Okay, that's it. That would be this vector. Right? And this is typically what happens when you take a matrix and you multiply it by a vector. It makes it bigger or smaller, and it will typically spin it around. It'll either go this way or that. This one just went, still kind of positive, but
you know, it could go down, it could go backwards, okay? Eigenvalues and let's ask GPT. This might be a better problem for Gemini. I'm gonna do this in my, I'm just gonna do it in a quick Gemini, which is A equals, what was it, 2, 1, 4, 7. Give me the eigenvalues and eigenvectors. Give me a second for the answer to come back here. It's thinking. It should be able to do this, but, okay. Okay, so turns out, so if you take, if I pull this off of a linear algebra book, I get some smoother numbers, but that's life. You take 2, 1, 4, 7, and you multiply instead this number here, first component 1, second component 5.7. Okay? So the computation process is part of what sklearn does for, if you multiply this by that, what you end up getting is, I'll put approximately, 7.7 times 1, 5.7. This is what's called an eigenvector and an eigenvalue. So what's happened here is, whereas most of the time a matrix multiplication will extend and spin the vector, if it's an eigenvector, when you multiply it by the matrix, you just get a multiple of the original one, which just means that instead it gets shifted. So we say we had the vector x is 1, y is 5.7. I'm going to actually put that way down here a second. So let's say x is 1 and y is 5.7. When you multiply this by matrix A, you just get something that is 7 times as big, so 7.7, and this would be like 37 or something. So the original vector looked like this, the new vector will look like this. It points in exactly the same direction, it's just bigger. That's what an eigenvector is. Why these are useful, there are many different reasons why. Linear algebra course will cover them, but we learned one of them, which is they are fundamental to PCA analysis. Okay? These are what are called essentially the fundamental directions of that matrix. Okay? All right, now, so let's take a look at the second problem that we're going to look at, which is related to the problem we did before. It's not that different. Let's get this plugged in again. So yeah, you can see I asked it to give me it went through the math for me. Okay, so let's go ahead and look at this second portfolio. So like I say, if I give you a Jupyter notebook, one of the things to do is always just go ahead and run the Jupyter notebook with the kernel. And if life is good, always click this button. I mean, you'll have to do it every time you launch a new session, but at least you don't have to tell it many times. The last row will turn to a star, which means it hasn't been executed yet, and it failed. So I've seen this before. It probably means I created something. I'm gonna hit save, of course. And let's get rid of this one. Let's put in another copy. Let's see where it fails. I thought I'd run this before I came, but let's just go see. Probably, it's coming along fine. It's making progress. It's doing okay. And it hasn't failed yet. And it's still working, doing a lot of good work. And why does it fail? I probably put some bogus stuff on. Oh yeah, right. So I did a little thing here which I shouldn't have done. So let's get rid of this. Let me get rid of that guy. this one, this one, this one. Okay, now the rest of it will run. So I had done some work with it when I was fooling around with it. One of the issues that Jupyter Notebooks actually have is that they're easy to change because you're looking at them, you can just type in them. That's a positive when you're trying to do exploration. But if you change things and then you save them and then you break them, or even worse, you make them look like they work, but you've actually screwed up a calculation, how do you know that you didn't screw it up? That's a similar problem that we've always had with Excel in finance, which is that notebooks are so easy to change, that's their big positive. On the other hand, if you change them, you might break something that's working and not even realize that you've broken it. Consequently, you generate missing numbers. All right, so let's see what this problem is here. So using, again, the author's rubric for setting up problems, or his template for setting up problems. Step number 1, problem definition. We want to maximize risk-adjusted returns. That's always the finance game, right? I want as much money as possible, but with as little risk as possible. Sometimes I might take more risk so I can get more expected return. Sometimes I'm a little worried and I'll give up some return just for reduced risk. More treasuries or more stock. Using dimensionality reduction-based algorithm, PCA, on a data set of stocks to allocate the capital into different asset classes. The data set for this study is Dow Jones and its respective 30 stocks from the year 2000 onwards. The data can be downloaded from Yahoo Finance. Now, there's been a number of changes in the Dow over the past 26 years. Probably maybe 20 of the stocks that are in there now were in there in 2000, or maybe only 15. You could look it up, what were the components. And the reason why the Dow is famous is because it was pretty much the first major stock index. Started by the Dow, I think Dow Jones probably first. Started like in 1926 or something like that, and continuously published. There are a lot of criticisms of it, the main one being that it's price weighted, not market cap weighted. So it's not as good an index for investment analysis purposes as any of the other indices, the NASDAQ 100, 500, S&P, et cetera, Russell 2000, Euro Stock 600, et cetera, right? The Nikkei. All right, so I don't know what the authors did to deal with the fact that the components were changing over the years. I didn't explore that. Obviously, this is a lesson. This is not an investment that I'm going to put money in. Okay, so anyway, that's the problem. Load the data in, right? Get the libraries. Pretty much the same libraries as before. Brings in this new thing called truncated SVD we didn't see in the last class. Also pulls in from the NumPy. NumPy has its own linear algebra, which has an inverse function, an eigenfunction, which will give you eigenvalues, and an SVD. SVD is a clever way to compute eigenvalues and eigenvectors that is more numerically stable than the standard way. Probably importing the NumPy packages to independently confirm what sklearn was doing. And then he pulls in something, these two, t-SNE and kernel PCA, we're not going to cover in this class. So next week we'll be off of PCA, by the way. We'll be into, I believe we'll be into trees, okay? Okay, so exploratory data analysis. Take a look at the stocks. Okay, here's 25 years of prices of 30 stocks. I'm guessing what he did was he probably took the stocks that were in the index the day he took the picture and just got those for the past 25 years, or this is 20 years, even if they weren't in the index in 2000. I'm going to guess that's what he did, but I don't know that. He gets the data type, so this whole stuff he did before. He gets the description, and you'll see something interesting here. Most of them have all of the data points, 4804. This stock, DWDP, only has 363. I wonder if that's a new stock. I don't even know what that ticker stands for. DWDP ticker, yeah, that's a stock. That's the DuPont quote. So I suspect, so if you go back here, it tells you, as of March 26, Dow DuPont completed its breakup with the successor company trading as DD. DuPont de Nemours. So, I mean, Dow's obviously, Dow Chemical, that would be, I guess, been around a long time, but so that, they had no data. So, you know, this will be, his solution's gonna be, he's gonna drop this column, because there's just not enough information there. And he ends up with only 28 columns, so one of these columns that is in the dot, dot, dot here, also gets dropped, okay? And then he does some data visualization, he builds a correlation matrix, 30 by 30, it's a little hard to really see, but you can see a lot of greens, which represent they're kind of the same. Cisco, for some reason, has this negative return with respect to, I guess, to 3M. That's kind of weird. It looks like they're all kind of negative to 3M. Kind of makes me think that MMM thing must not be whatever he thinks it is, right? Are they? Oh, they're not negatives. They're just. I think this sign is just a hash mark on the side of the. Okay, so it's 49 and 54. It's not negative 49. Okay, that's a weirdness there. Okay. DWDP has all these weird numbers in it because it doesn't really have enough data to correlate. He does data cleaning, and then he goes through these steps. I'm not going to cover all of them, but he talks about here how to get rid of them. Some of these commands, dataset.isNull.values.any, there are the net result is there definitely are null values, and he gets rid of the columns with more than 30% of the data missing. Now, you know, again, 2 years ago, you probably have to figure this command out for yourself. If you're building this notebook, you know, you learn, having done Python for several years, you've learned all kinds of cool tricks, and you can build this thing yourself. Now, you know, it's not like that anymore, right? Okay? Not to be the, so he gets up with 28 columns. So 2 of the variables had more than 30% of the data missing. He does some filling algorithm here. Okay, now kind of interesting, daily log returns. This would be, normally I always do log returns. You take the data and you divide it by the data from the previous day, and then you take the log, which is always the natural log, and that's a return. Instead, for whatever reason, he does linear returns, which is percent change 1 day back. So it takes the price at 100, takes the previous day at 98, does 100 divided by 98 minus 1, and that's like 2%. Whereas the first one says take 100 divided by 98, take the log. Will also be like 2%. From Taylor series, basically, the percent change is a cutoff of the continuous return after 2 terms, continuous time mathematics, you know, which like with the Black-Scholes option pricing formula is based on, typically likes continuous returns, log returns, that's a kind of a fine point. Then he does this interesting step here: remove outliers beyond 3 standard deviations. So he applies this little snippet of code where he takes the mean's absolute value, and if it's less than 3 standard deviation, you keep them. Otherwise, I guess you dump them. He gets rid of them. And removing the outliers. This sometimes might be called Windsorization, which is that you only look at you ignore all the data in the bottom 5% and the top 5% if you want to think that is more representative of your problem. It's an interesting question in statistics. We're not going to cover it right now, but I'm sure Professor McDonald probably uses it regularly. You know, this is a choice made by the author. You'd have to ask yourself, well, why does he make this choice? And would I replicate this choice? Because certainly if you went ahead and copied this code, something you're working on for your boss, the boss might say, why'd you do that? And you'd be like, well, because the book I had, they did that too. And be like, is that good enough reason for you? And they'd be like, well, no, of course not. It's okay, come back to me. All right, so data transformation, this is the process, and this is again he does the same fit in line 1 and fit transform in line 2. I question whether that's really necessary, but I'm gonna let it stand for now. He drops out stuff that doesn't belong. He rescales the data set. So he gets this new data set which looks like this. The original data set is not printed here. I think I may have saved it. I guess it's a different notebook I had saved it, but let's go ahead and let's get the data returns command Okay, so in this case, so far, he's scaling he's working on the returns, he's not working with the prices. Pretty typical, you work with returns, not with prices. We're gonna stop a little early, then, just so you know, but about 10 or 15 more minutes. So the original returns were like 2%, 4%, 5%, negatives, and this is a plus 7%. He goes ahead and he scales them, and he gets these new returns, which are standardized with a mean of 1, right? A mean of 0 and a standard deviation. Right? When you take all the z-scores, right, you're rescaling it to have mean 0 and standard deviation 1. That's what the standard scaler does. Okay, and you can see these kind of hover around 0, and not all, usually between 0 and 1. I mean, there's different rows. This, you can see a big return of 7 yields a 108. This one was 0.02. Yeah, it's not really, well, there's a lot of different things going on, so we can't tell from the 26 years of data by looking at 2 rows what is sensible. All right, and then this is a graph you'll often see around returns of data. The fact that you notice that they run, there's probably some scale over here. I guess these are the standardized. Are these the standardized? Yeah, these are the rescaled set. Goes from -4 to +4. So this is probably similar to the normal distribution in the sense that most of the data falls in between -3 and +3. If we took a less volatile stock than Apple, the range would probably be compressed. The fact that sometimes you get really crazy lines, this is obviously the equity bubble of 2000, the NASDAQ bubble. And you got your 2008, look at some of the big moves in 2008 when the stock market was crashing down, 2009. And this is often what's called evidence of stochastic volatility, which says sometimes the market is really crazy, other times it's relatively calm. And a lot of models assume that the volatility is always a sort of constant level. You have to factor that into your thinking, and you see, well, it's clearly not constant. All right, go ahead and he goes ahead and does the principal components, and he gets the first principal component, and again, maybe unsurprisingly, all of the principal components are positive in the first principal component. This will be equal to something related to beta. It's like all stocks kind of move in tandem with the market. All right?
Everything I have is negative.
What's that?
All the ones I have negative.
For this guy here?
Yep.
That can't be.
Uh,
Can't be. I just sent you this material. Oh, okay. Yeah, oh, good question. All right, so this is kind of interesting. In his notebook, all of these numbers are the same as mine,
Yeah.
except negative. The reason for that is that when you have an eigenvector, which goes like this, the one that points in the exact opposite direction is also an eigenvector and has all negative components. Normally, I would have thought that this thing would just go ahead and force the first component to be a positive number, and then adjust all the other ones would flip the positive. Why it didn't happen there, it's kind of interesting. How your computer ended up with only positives and negatives, mine are only positive, that's a question beyond my pay grade in computer science. But it's good to know. It would be a good question to ask your LLM. It will tell you what I told you about every eigenvector that points one way, its opposite is also an eigenvector. Remember what eigenvector means is that the matrix multiplication just scales it. It doesn't rotate it at all.
it just puts it on a factor.
It just
multiplies
makes
by
it
factor.
bigger or smaller. If the eigenvalue lambda is bigger than 1, it makes it bigger. If the eigenvalue is smaller than 1, it makes it smaller. If it's exactly 1, it means the vector gets unchanged by the matrix.
So whoever wrote the code really should take the absolute value.
What's that?
Whoever wrote that piece of code really should have taken the absolute value of it.
Well, you don't necessarily always want, you wouldn't want that, right? Because only this component has all positives, right? But the next principal component will have some positives, some negatives. You certainly wouldn't want to make them all positive. I think it's often the case that these algorithms will decide to always make it so that the first component of the first vector is a positive number, but I guess that didn't happen here.
And now we get, you know, the equity market is more interesting from a principal components perspective than the interest rate market, because you can see the different, there's 30 components now, not 10. The different components, 37%, another 5, another 5, another 4. They are less determinative than they are in the case of the interest rates. And then he gives these nice graphs. This is the same picture I think we saw before, which shows you how much each, it's good to know that the first component does explain a lot of the variance, but it's only 40% a lot, not 90% a lot, okay? We work with a different data set in our version, which was we had 7 ETFs, I think, one for each different sector. Here we got 30 stocks, okay? So you look at the portfolio weights, these are the PC components. And the so-called weights in the eigen portfolio is a rescaling. So you take all of these numbers and you what you do is you divide by the sum of the, so you add up all these numbers in this row, these 30 components, add them all up, and you take every number and divide it by the sum, so that they all sum to 1. So this new thing says that this thing here is 4% of the total weight of all the numbers here. And you can see for the first principal component, you got 4%, 4%, 3%, 3%. They're all roughly around 3.3%. If we had 30 identical components, they'd all have like that percentage. So this is what he's going to call an eigen portfolio. This is the eigen portfolio associated with the first eigenvector, which is to take all of these things and weight them. So the first eigen portfolio will have, if you put $10 million into it, it would put 4% into each of the stocks, 2.9% and so on. And that will be the portfolio, yes?
My lines jump from 18 to 69.
Okay? Well, that's because you're working in it. That's another weird thing about the notebook. If you jump around, like if you look at the very bottom of your notebook, 68 is probably the last number that was there.
Yeah, I see it now.
Yeah, so that's just telling you the order in which it was executed. That's another thing about using notebooks, is that you can go back up, after you've run the whole notebook 68 times, right? 68 lines, you go back to the top and do something else, and now line 69 will be up here. But you don't know how what you just did affects what came above, what came before. Problems with notebook, but they're useful to use. They are useful. Okay. So what we end up, he creates 5 eigen portfolios. The author, I should say, they create 5 eigen portfolios based on the same. Like if I do this here from 0 to 5, let's just try this. Let me go side up here. The data frame by giving the data. Let's do it. This should work. Yeah, so you can see that the first one, the 23 is 22.7, 2.28, 2.28, 15, 15. That was the first principal component. These are the 5 principal, these are the first 5 out of 30 principal components. The authors make an eigen portfolio out of each of these by doing this rescaling to get them down. Where was the percentages that we had? Oh, the portfolio weights down here. Right? It takes every one of those vectors and rescales it and says, okay, now I'm going to create a portfolio whose weights are equal to the relative importance of each stock in each one of the principal components. These will be my 5 eigen portfolios. Okay, for the last thing, and I'm going to stop. These are what the portfolios look like. So portfolio number 1, let's look at one at the bottom. Portfolio number 4 has this weight on 3M, this weight on American Express. So it's long 3M, short American Express, long Apple, long Boeing, Caterpillar, CVX, that's railroads, I guess.
Neutral on Disney.
Short Cisco, long Coca-Cola, a little bit short Disney, ExxonMobil, Goldman Sachs, Home Depot, IBM, Intel, etc. Most of those companies are probably still in the index.
okay, Nike, all right? And then he says, okay, well, are any of these any good? That's his question. And he goes ahead and he normalizes. So what happens is you have a lot of positives and a lot of negatives. The total weight of your portfolio is gonna be like 0. That's your classic, I buy a lot of stocks and I sell a lot of stocks. I'm gonna try to pick the good ones and, short the bad ones. But he goes ahead and he I guess I did this myself. That was me working. Then what he gets into, he said, let's just see what where he ends up finding the best one. So he goes ahead and computes a Sharpe ratio, which I'll talk about after I show it to you. The Sharpe ratio is basically you take how much you get, the returns you get on the portfolio, and you divide it by the volatility, okay? So if you earn 20% a year on this portfolio, and your standard deviation of return is 10%, your Sharpe ratio will be 20% over 10% equals 2, which is an excellent Sharpe ratio. If your return is 20%, but your volatility is 40%, now the ratio is 20 over 40, which is 0.5. Obviously, if you can make 20% a year, that's great. You'd rather do it with 10% volatility, like every year is like pretty close to 20, as opposed to 40% volatility, which is some years you get 60, some years you get minus 20 to achieve the same effect, or minus 40, I suppose. Okay? No, minus 20 is right. Minus, whatever. That's called the Sharpe ratio. So he runs all of these portfolios against the history. He runs them for all 30 principal components, and he finds out that the eigen portfolio associated with the principal component has the highest Sharpe ratio. A good Sharpe ratio is often thought to be about 1. S&P 500, I think the Sharpe ratio often around 0.5. Good enough, you're in it for a long time, doesn't matter, but good hedge funds will aim to have strategies that get higher than 1. It's hard to, like an HFT, a market making hedge fund, it might get strategies which have a Sharpe ratio like 4 or 5, which means they're making 4 times as much money as they're risking, relatively speaking, but those can only handle very small piles of money because there's not enough liquidity. And a lot of these are not really that great ideas. This is an idea, like, can I make money using the eigen portfolio? The one thing he didn't show here was he didn't show the eigenvalue portfolio. He didn't show the Sharpe ratio, I should say, of the full index, just on the index. That's kind of missing from that. But he does. He goes on and does a back test. So what he does now, so principle. He spelled, yeah, this is the wrong spelling of principle. It's not a principle like I'm going to stand on this principle. It's the principle, meaning the main component, AL, okay? I didn't cover this, but I know he covered this with Professor McDonald. He did divide the data set into training and test. So he trained on the first 80% of the years, and he saved 20% as test. And what he's doing with this is, okay, based on what I thought was the best portfolio from the 80%, how does it work out in the 20% which was not used to fit? And he comes up with this story here that portfolio, this is the eigen portfolio versus the equal weight had a return of whatever over 10 years, over the period from 2015 to 2018, returned almost 187%, so about 87%. Whereas the eigen portfolio, the first one, looked like it was doing very well for 2018 and then came off. This one had a return of 99% with a volatility of 50. This is the next one. I think that's the first one. So, this is the original one, returned 32% with a volatility of 68. So a Sharpe ratio of 4.8. I guess this is right, 32% per year, right? It starts out at 1 in blue. It ends up at 2.5. So I think if you take 32%, let's just do the calculation quickly. Let's put a cell here. Let's put the cell down here. So many graphs. Hold on a second.
So if we take 1 plus 0.33% to the power, I think this is, how many years is this? Goes from summer of 2015, that's about 3 years. The power 3 minus 1, no, doesn't like that. Python uses star for exponents. You get 2.35, so that's all he did there, was he showed, I'm gonna fix this box in a second. So you can see it does end up right around 235. If I were to be more exact, I'd get the exact number. There's a way to make this thing not scroll like this, and it is to click on this. No, that's not it. Hang on a second. Let's see. There's a way to make this thing expand to the full. Oh, I gotta do a right click, that's what it is. And disable scrolling for output, so I get the whole picture. So this one did a Sharpe ratio of 0.5, pretty much like the market, I guess, which is actually what we managed. This Eigen portfolio, I don't know which one this was, but it had a great Sharpe ratio of 1.71. Now, it made 100% over the 3 years annually, right? It ends up at like 8, so it's compounding. But it did have 58% volatility, which means it had these, basically this big drawdown right here is driving a lot of that volatility, and so on. Okay, so start looking at this material. I think the book is, if you find a copy of the book inexpensive, it's probably a good read. I think you'll like it. I have a better book, but it's not coming out until the fall, like I said. I was just chatting with the author during the break, actually, because I've been helping with the debugging of the notebooks. It's going to be a great book, but it's just not in print yet.
To confirm, you're saying the machine learning and data science blueprints for finance?
Yes, not a bad book. But it doesn't go into that many details, as many as I'd like, but it does lots of interesting stuff, so that's the trade-off. The other book, which is going to be 1,200 pages, it goes into a lot of detail. You're going to really want to be committed to studying that. Okay, we'll be back next week. I'll put some assignment out, see if you can solve that problem as to why they don't work. It's kind of, it'll be, if you find it, you'll be happy, because it's an interesting fact that you have to keep in mind when you're doing principal components analysis. Okay? That's it for this week. Thank you. And like I say, anybody wants to talk to me anytime, just send me an email and I'll set up a video call that we can talk, and you can show me anything you want to show me. One more. Every night.